Hi everyone, and welcome to what hopefully will be a fairly quick video to run through my workflow in terms of modelling 3D objects and then 3D printing them. So here we are in Fusion 360, which is where I always start. I'm not going to do anything major on this one, but what I do need on my cockpit is a quick adapter plate because I'm mounting an amplifier onto it which will power a bass shaker under the seat. So yeah, here we are in Fusion and we've got a sketch in front of us. It's a fairly simple thing. So we've got basically a rectangle, we've got some holes or some circles which will be holes for various bolts to attach this plate to the cockpit frame, and then these two holes, smaller holes here, will be to attach the amp to the plate. And also what we've got is the larger holes on the outside, which will essentially be countersinks so that the heads of the bolts that we use don't protrude anywhere that we don't want them to. Okay, so that's the sketch. Quick extrude essentially of the main sketch shape, and then some selective extrudes on the countersink areas just to make those countersinks. Leave the holes in the middle obviously out so that they go all the way through, and you can see there's a countersink on the other side here as well, because this area here will be flush up against the cockpit frame, so we've got to have a countersink there, otherwise we won't be able to bolt it on flush. Right, so there's our adapter plate. So we need to get this plate onto a 3D printer, but before we can do that, it's got to be essentially sliced in the Z-axis from bottom to top, so that the printer can build it up. And basically 3D printers use G-code in the same way that any CNC machine, or pretty much all CNC machines, use G-code, which essentially is a set of instructions that just point the print head to go to various coordinates in the Z, X and Y axes. Click on the Make button, and Fusion 360 can print out, I think, directly to some 3D printers, but I'm using an application called Cura. So we select Custom from the print utility, and then application, point it to Cura, and then we need to select a body for it to print. Click on OK, and then we wait for Cura to load. Now Cura's it's essentially an open source piece of software, but it's maintained by Ultimaker. And the version I've got is 2.6.1, and there we go, it's loaded up. So what we have here is our model in a virtual representation of the printer bed on the bottom here, the checkerboard piece, and also it shows you the volume in the Z-axis as well. And if we click on the model, we can use scaling, we can move it by dragging and dropping on these handles here. We can rotate it, which we will do here because I want it on the longitudinal axis of my printer, so we'll just move that there. We can actually do mirror operations, and we can also do some more advanced settings where we could have duplicates or multiple models, if you like, on the print bed, so we can print them all out at the same time, and we can set some settings for each one. We can also look at this in a layer view, which actually is sometimes more useful because it shows the actual lines and toolpath lines it's going to follow, the path basically, and you can see that we've got the brim round here which is going to stick this model hopefully to the printer bed. I won't go through all the settings on the right here, but basically you can set things like layer height, you can set infill so that you can put a honeycomb inside of large solid objects so that you're not printing, you know, kilos worth of filament plastic out in one go. There's various temperature and speed settings. It can also generate supports if we need to. Don't particularly need to on this particular model, but you can generate support so that it support overhangs, which of course 3D printing can't do. Certainly not FDM kind of printing. Okay, we've got two options here. Now we can print directly with Octoprint, but I don't use that. What I tend to use is a save to file, and I save both the G code, which is what this will generate. So if I click that, and you see I've already saved it here, so it's ampplate.g code. I won't actually do that and overwrite this one because we're actually going to print this. So let's just cancel that. And the other thing I do is I save the project, and the reason I save the project rather than just the G code, which is the instructions essentially to the 3D printer to actually do the 3D print, is because this file contains the 3D model or version of it from Fusion 360, plus a bunch of the settings that I've just set. And what it means is I can use that project file to just print directly rather than going into Fusion 360 and going through this part of the workflow again. And also I can just drag and drop multiples of this object onto the print bed and print more than one at the same time, which is obviously useful for things like the end caps on the extrusion for the cockpit. So having done that, we then need to actually send this G code, which is here, look, to the printer itself. Now the software I use for that is a piece of software called Octoprint. Again, it's open source, I believe. And what I've done is I've loaded the Octoprint software onto the Raspberry Pi that you can see in one of the recent previous videos, so where I make a case for that. Essentially what that does is it acts as a controller for your actual 3D printer control board and enables it on the network. So you can see I've got it on a 192.168.06 address on my network that can then start and stop jobs, and you can monitor it. So you can see that here we've got a status of the printer, it's just operational. We've got a list of files that are on the Raspberry Pi and in the SD card that's on the printer itself. So you've got two places you can save files to. You can load it to the Raspberry Pi and then you use the USB interface from the Pi to the printer to essentially control the printer. So it'll send various, the various control G code messages down to the printer, and the printer will execute those. Or you can actually load it onto the SD card, which takes ages because of the baud rate and the size of some of the files, onto the SD card on the printer itself and print from there, which is more reliable from a communications perspective. But as I said, it takes hours sometimes to load some of the larger print jobs to it. I'll show that now. So all we do to get the file onto the printer, and the printer is actually in another room. In fact, it's in my workshop next to the CNC machine or near the CNC machine, and I can just drag that and it gives you the option to either upload to the SD card or upload locally. Actually, you can't see that. Let me just move that onto the screen and see if you can get that. There you go. See, upload locally, you just drag and drop there. Upload to SD, you can drag and drop there. So I'm just going to upload it locally. You can see it uploading. Took a few seconds and it's ready to go. So you can click on that and you see that the active file name has come up in the status piece, and we could just print. But first of all, I'll show you a few bits and pieces on the printer, and we don't need to go to the printer because what I can do is go to this control section, and we can actually see from the Raspberry Pi camera that I've got mounted on the 3D printer, and the mount will be another video. We can see the printer in its current state. So what I've done to prepare the printer, actually don't really need to do a lot. You basically just need to make sure the bed is okay to start printing on. Now I use masking tape on my bed. I'm going to get some glass actually, I think, to put on there at some point. But masking tape seems to work quite well, especially if you give it a quick scuff with some, 240 grit sandpaper, somewhere around there. Just roughens it up so that the molten filament, when it comes out the extruder head, can stick, if you like, to the fibers in the masking tape. That works quite well. Sometimes it sticks too well to the bed, but at least with masking tape you can actually peel that up and get the object off of the bed as well. You can even control the printer from here, so you can see that moving hopefully, and there's the print head coming into view, and we can move the bed, there we go, and we can also move the print head up and down, right, and make various setting changes from here. The terminal is quite useful because you can actually see the print instructions coming from the Raspberry Pi to the printer control board, and you can see what it's doing here is going for an M105, which is tell me what the temperature is of both the bed and the extruder head, and the printer is receiving that okay and then reporting back what those temperatures are, and that's where this graph comes from, which is a graph of your temperature, and you've also got settings under here as well. So you've got a graph trace for the bed, and you've got a graph trace, which is the red one, for the actual hot end extruder head. There's also a time-lapse option, so you can see there it records a screenshot every 10 seconds. There's also a 10-second post capture as well. Basically what it does, it takes those screenshots, and then when the print job's finished it compiles those into an MPEG file, which then you can download directly. And I'm just using this from Chrome, so you can access it from anywhere that you can essentially access the Raspberry Pi from on your network, just using a web browser from any machine. Anyway, we're ready pretty much to print, so we've kind of prepared the printer, not that it needs much prepping, and all we do is we press the print button. Now immediately the bed, you see that's changed to 50 degrees C there, and also the blue line there has changed to 50 degrees C, and you'll see the dark blue line rising up to meet it. And we'll probably time lapse this because it will take a little while just to heat the bed up. Okay, so we're just about 50 degrees C, so 49.8, and what happens now is the hot end extruder head temperature is then set 205 degrees C. You can see the pale red line shooting straight up to there, and then you can see the dark red line rising up to meet it as it tries to hit the target. What it does actually is it heats up to just below, I think it's 5 degrees below, so 200 degrees C. It will then kind of back off for a little bit because it doesn't want to overshoot and then start porpoising, if you like, around the temperature line, although it does it always a little bit. And then it'll gradually heat up to the 205, and then the print job should start. So we'll just wait for that. Actually, while we're waiting, probably worthwhile noting that the Raspberry Pi from this point onwards is essentially autonomous. You can send commands down like pause and cancel and stuff. If you closed down this browser window, went to another machine, decided to go for a drive or something like that and come back, this would still be operating, and you just basically log in again to the session on the Raspberry Pi through the web browser and pick up from where you left off. Okay, we're nearly there now, so it's kind of, see, it's just backed off a little bit, and then it's going to gradually creep up rather than full power heating. And then what we'll do is we'll step over to the control piece. Yeah, it's pretty much there. And right, so we can see now what it's doing is it's actually going to the machine 0, so it's gone to the limit sensors on the bed here, and it's also gone to the limit sensor on the carriage, so that's the x-axis, that's the y, and now you see it's lowering down to the z. Then what it will do is it will start probing the bed out, and what that does is take 9 readings when it gets down there. So it's just gone down, got to the Z0, and there you go, it's starting the first of the 9 readings. You might even just be able to see the light on the back of the green sensor on the back there light up. There you go, as it kind of reaches the calibrated, physically calibrated 0 point on the bed. So we're now on the 4th reading, so it'll do those. What it's doing here is it's taking a number of readings, and much like Mach 3 actually can do as well on the CNC machine, it can adjust the G-code Z-axis that it's using to compensate essentially for the bed not being quite level. It's a very useful feature. If anybody is buying a 3D printer, always try and get one with the auto leveling. You can, with the Prusa design, you can retrofit it, but it just saves a lot of aggravation if you've got it on there to start with. Okay, so what we should start to see now is we should start to see some black filament, I hope. There you go. Actually, you can just see it starting to extrude. And first of all, it's just going to do the bed. It's got a bit stringy and messy there, but that's okay. And the first couple of layers basically will sometimes be a bit messy just because it's not right, you know, to 1/100th of a millimetre accurate on the height of the bed. But what you tend to find, providing it's not a great big lump of filament lying on the bed, it will run the extruder through it and kind of smooth it out. So that's not too bad. And basically we're underway. We're now printing, and we just have to wait for it to finish now. So anyway, hopefully that was interesting, and as ever, thanks for watching. I'll catch you on the next video.